It's not Miss Neville, it's Teams. If you had a hard time getting in today, I want to apologize. It's not Miss Neville's fault, the reason why you couldn't get in. Cadence, do me a favor and turn your camera off, please. Cadence, do me a favor and turn your camera off, please. Thank you. You're about 5 seconds from being kicked out. All right, so let's go ahead and get started today. So we're going to be talking about radiation. We've been talking about the three methods, the three ways that heat transforms from one form to another, the way that heat moves from one place to another. We're going to start discussing radiation. And so when we talk about radiation, we're talking about heat waves. Have you ever seen those before on a really hot day? Let's say it just finished raining and you see the little waves coming up from the sidewalk or the street. You can almost see them in the air. It makes the air look fuzzy. Yeah, those are heat waves. And the learning objective for today is the students will be able to use models to identify the source of heat transfer through radiation. So whenever Ms. Neville's talking about identifying models, we want to be able to look at an image, look at a picture, and be able to explain what's happening there. Okay? Please make sure you have your colors with you. Please make sure you have your colors with you, as you'll need them today. So what is radiation? Please write down the notes that you see here. Radiation is when heated particles move in the form of waves. Yes, they move in the form of waves. These particles do not touch one another as they travel through the air. Okay, unlike with conduction, direct heat on an object, those particles are constantly hitting each other. That's what causes combustion or fire that we see with conduction. With radiation, the particles that make up those heat waves are spread out and never touching one another. Just like you see here with the gray model here, these are particles that are spread out that are traveling through the air. We want to add to our notes that these particles do not touch one another as they travel through the air. So unlike the particles in conduction, particles in radiation do not touch each other as they travel through the air. Please draw this picture as well. You want to label those gray little spheres there. You want to label those as particles, heated particles. Notice how they're spread out. They're not touching one another, okay? And they never will. Kaden, go ahead and unmute yourself and tell us what you need.
Oh, do you need to write this stuff down? Because I can't hear you because the baby was screaming.
Yes, you do need to write this down.
Okay.
So when we're talking about conduction, remember conduction is direct heat on an object. Convection is heat rising and cold sinking, the circulation of heat. And radiation is heat moving in waves. And so we've got three little hand movements to help us out there. Damon, go ahead and unmute yourself and tell us what you need.
Are we supposed to draw this picture?
You are, yeah. You don't need to do the labels there where it says electrons and all of those things. Ms. Neville is about to move on. Remember, this lesson is being recorded. So if I'm going too fast or I'm moving too fast, it's okay. You'll be able to get these notes later on. I'll give you another minute. Henry, go ahead and unmute yourself and tell us what you need.
Yeah, well, I tried to get in the meeting. I tried.
I know, buddy. It was Teams. Teams was showing me that you were in the lobby, but I couldn't let you come in. I had to call some students, but through their parents' phones and be like, can you please leave and I'll invite you in. I'm sorry about that. This lesson is being recorded if you missed any notes, okay?
All right.
I'll give you about 2 more minutes. Okay, so where would we see radiation? Where would we see radiation? Well, let's look. Here, these old school computers show us that these that when you remember the back of the computer got really hot, some of our TVs still get really, really hot in the back when they've been on for a while. Yeah, that's radiant energy coming from that. Okay, that's radiation, that heat traveling in waves. And I want you to write down this sentence. Here we see radiation is emitted. Try to say that word, emitted. Emitted just means to give off. So let's say if I did something like, oh, I don't know, pass gas, a stinky smell is emitted. Okay, it's put out. And so radiation is emitted from a place when heat is given off. Like at a campfire, radiation is emitting from that fire. From a heater, if I put my hands near it, radiation, radiated heat particles are being emitted. So that word emit, E-M-I-T, means to give off. It's important that you know what that word means. I promise you'll see it soon. Hint, hint, hint. You don't need to necessarily draw this picture. I do want you writing down these notes here. We need to know what emit means. Okay. So when we're looking here at radiation, the next question we need to write down in our notes is, what is the best source of radiation? Remember, source means production place. Source means production place. So when we're thinking about the largest source of radiation, where we can see the most radiation being produced, it is the sun. The sun is the #1 producer of radiation, radiated heat. Okay? But anything that's hot, anything that is emitting heat, is going to have radiation. I tried to take a picture of it. We see here with a campfire, those little waves in the air here. Yeah. Anything that is giving off heat is emitting radiated waves. Heated particles that travel through heat waves. So that's our lesson for today. This lesson has been recorded. So if you were missing any notes, I want you to know that this lesson has been recorded and you'll be able to see